What's up guys, welcome to the 10th tutorial in our Python language basics. Here we're going to cover the topic of multi-dimensional lists. This is a direct follow-up to just regular lists, and we have a fairly short one ahead. So we'll just talk about creating two-dimensional lists, or matrices as they're often referred to, and then how to access and modify the entire lists within lists, or just individual elements. So let's head on over to the code. Now the first thing I want to do is get ourselves a cell started up. I am assuming that you are comfortable with lists from the previous section. If not, then make sure you are moving forwards, because it's about to get a little bit weirder. Now the very first thing we need to understand is that multi-dimensional lists are really just lists. Okay, we can treat them as regular lists, but instead of each individual element being just a single value, it itself is a list. Common sense would be to think, if this is your first time with multi-dimensional lists, you should really structure things this way. I think it personally makes things a lot easier to see, because now we can kind of understand the two-dimensional structure of it. We can very clearly see the rows and the individual columns. Okay, now this is one big caveat to two-dimensional lists, is that they don't all have to be of the same length. Okay, we have 3 elements here, we have 4 here, 2, and then back to 3. And that will happen a lot. Okay, so that means there's an extra level of checking that we have to perform. We not only have to check the length of the entire outer list, so that would be 4, but we also have to check the length. However, that's pretty easy to do. In our case, we know exactly what the structure is, so that's fine. We know if we want this one, we know it's at row 0, 1, and 2. Okay, and we know it's a column 0 and 1. In fact, let's go ahead and fetch that. So let's say we want this world. It is the 1, 2, 3, 4, 5, 6, 7, 8, 9th world. So let's call it that. And this is going to be our universe. We're going to first get the row. Okay, so in this case, 0, 1, 2. It's row 2. And then beside it, we now need the column. So in this case, 0 and 1. Okay, and let's just go ahead and print out 9th world if we really want. Okay, so let's go ahead and run that, and we get 2. So that's exactly what we would expect, because we're accessing the second, or the index of 2 for the row there, and then the column of 1. Okay, obviously this wouldn't work if we tried to access the second column, because this doesn't exist. So that's why, again, you'd maybe want to perform an extra level of checks. Now, modification works in exactly the same way. I could change up this if I wanted to. One thing actually I didn't mention in the previous section, which perhaps I should have done, is that if I change 9th world, this has no reference to universe. Okay, so if I change up this variable called 9th world, then universe won't change. So if I say something like 9th world is equal to 5, okay, and then I print out universe, alright, you'll see that it hasn't changed at all. So this was basically copied into 9th world. We reassigned it, but universe doesn't change, and that's because we are copying the value. So when we do something like this, we're actually just copying this value that we find into this variable. Okay, if we change this variable here, it holds no reference to here, so this is unchanged. Okay, so that's something very important to note. This might change when it comes to using objects and classes, but more on that much later. Okay, so if we wanted to change an element, we can absolutely do so. Again, just access the row and column. Also, these are just regular lists, okay? Just as this outer list is still just a regular list. So we can absolutely add items to it. For example, let's say I want to add something to my universe. I want to add in a whole new world, okay? And no Aladdin references there, please. We're going to take the universe and we're just going to append a new list to it. Maybe I have 1, 2, 3, 4, and 5. Okay, then if I want to print out my entire universe, I totally can. You can see that we have the other item, the new world, added to it. Okay, if I wanted to maybe add in a level to this guy, then I can. In that case, I would do this. I would say universe of see, we want row 0 and 1. okay? And in that case, I'm accessing this whole list. Okay, so universe of 1 is this whole list rather than just an individual element. So in this case, I want to maybe, actually, you know what, maybe I'm going to remove this item. So I'm actually going to do universe.pop. So I only want 3 levels in this particular world. Then I'll go ahead and print my universe again. And you can see that the second world has been reduced to only 3 elements. Alright. So, that's pretty much all I wanted to cover. I know multidimensional lists, as soon as you hear the word multidimensional or matrix, things start to seem kind of scarier than they actually are. Really, they're just lists of lists. We can treat those lists as individual values, and well, that's kind of it. Like, each of the elements is just a list rather than a single value. Otherwise, the same functionality really applies to the outer list as to the inner list, okay? We just have to perform one extra level of checking if we don't know the length of each of these, and then we need to make sure that we're accessing row, then column, and not the other way around. Okay, so that's it for now. This is definitely something that I recommend you practice until you've really got the hang of it. You understand this row column structure. Again, you can have any type of variable you want in there. We just happen to use integers here. When we come back, we'll be exploring the next collection type, which will be tuples. So stay tuned for that. Thanks for watching. See you guys in the next one. Hello guys, and welcome to the 11th tutorial in our Python language basics. Here we're going to explore tuples. We'll follow a simple elements and then take a look at the biggest difference between tuples and lists. And the one thing that we really need to remember here is that tuples are immutable, which means they cannot change. They're just there to store values one time, whereas lists are mutable. We can add things to them, we can insert, we can remove things from them, we can change the elements, etc. We can basically do anything we want with lists, but tuple is somewhat similar. We can basically create them as we did with lists, where we have the name and then the assignment. However, because it's a tuple, we actually put these in just regular parentheses. So one example of this might be if we were to have, let's say, an inventory, coming back to this inventory example, but we want not only the item name but also the quantity. Okay, you'll very often see this with any kind of like RPG game. My first thing that comes to mind is like health kits or some kind of food, something that you eat to heal yourself, something that you consume, because usually you have more than one of them. Okay, so a tuple might look something like this. Okay, so we'll say something like item is going to be equal to, and then in the parentheses we put our values, again separated by commas like with lists. Now tuples are a great place to hold kind of multiple different types of variables. We know that we can do this with lists, but you'll see this more often with tuples. Okay, so we might have the item name here. Let's do something like health kit. Okay, and then we'll have the quantity. Let's say we have 4 health kits. Okay, so this would be an example of a tuple. We can put as many values here as we want. We do other stuff, we can do true or false values, whatever we want. We can have it all be of the same type, we can have these all be strings if we want. But in our case, we'll just have the 2 values. Okay, so these are index-based, just like lists. So if we want to access a specific item, we do so based on its index. So for example, I could say name is equal to item at the index of 0, whereas this guy would be the quantity. Quantity is equal to item of 1. If we want, we can go ahead and print out name and quantity. Let's just do those to see. So we'll go ahead and run that cell, and absolutely we can do that. Now the difference comes in if we want to change these. So let's say I wanted to say, actually, I'm going to just cut that out and I'm going to paste it in here, but I'm not going to do any kind of assignment. I'm actually going to say item of 1 is equal to, maybe we have 10 health kits, we picked up a bunch or something like that. So now we want to print out the item to see how it changes. We actually get an error here. Okay, and the problem is, again, that tuples are immutable. So we've assigned this, and even though we're using the proper syntax and all, we can't really change them. Okay, not only can we not reassign this value here, but we can't add anything to it or take anything away from it. So that means no appending, no inserting, no popping, no clearing, no removing, none of that. Okay, we can, on the other hand, set item to be something completely different if we want, because that's not actually modifying the value of this tuple, that's just storing a different value at this location. Okay, so for example, let's say, obviously we can't do this, so let's go ahead and comment that out. But let's say I want to assign this a different value, so maybe I'm doing something like, I don't know, knife. Okay, and I only have one of these. Alright, now I'll go ahead and print out the item. That should be fine. You see no problems there. Again, because we're not actually modifying these values, we're not modifying the value of the tuple, we're just kind of reassigning, or rather assigning a different value to wherever this variable is stored. Okay, so that's a big thing. Now, because there are no kind of modification functions, there are only really 2 unique tuple functions that we can call. And these are going to be count and index. So count is going to be used to return how many of a specific item exist in the tuple, and index is going to return us the lowest possible index, or the first occurrence of a specific item. So I know that's kind of hard to process just hearing me talk about it, so let's see these guys in action. So what we could do is, let's say, within this tuple item, now it's knife in 1, we want to return the number of times that knife comes up. Okay, so we're just going to print out item.count, and then within count we're going to put knife. Okay, and this is going to return us 1. Makes sense, there is only 1 knife in this tuple. If for whatever reason I had another one, it doesn't really make much sense in our context, but we could do that. We'd have 2. Okay, and the index, on the other hand, returns us the first index of an item. So let's say we want item.index. We don't want knife, we actually want index of 1. Okay, well that's going to return us 1. Again, makes sense. There is only one 1, and it is at index 0 and 1. Okay, so that's just going to return us the first index. If we try to search for something that doesn't exist, okay, then that's actually not even going to return us 0 or something else. It's going to give us an error. So we always want to make sure that we have this item before we search for its index. One way you could do that is by saying what is the item.count of whatever element we're searching for. Let's say count of this, and then if it's 0, then we're not going to search this. If it's 1 or more, then we can search it. Okay, so that's kind of how you'd circumvent that issue there. Otherwise, we can get some other properties of a tuple, just like with lists. Actually, on that note, these two functions also are attached to lists. Like we can call count and index on lists, and they work in exactly the same way. But if we want to call upon these three functions, for example, length, max, and min, we absolutely can. So let's just go ahead and just demonstrate that there. If we want the length of item, okay, max and min of items, then we can absolutely do that. Oh, and let's see. Well, we should be able to, except that of course we're trying to compare two unlike values, so it doesn't really make much sense. If we had reassigned item to be something like 1, 2, and 3, okay, then that would be totally fine. We can absolutely do that. But again, just due to the dynamic nature of Python, we do need to do some kind of type checking to make sure that we are trying to compare reasonable types. Absolutely, it was right to give us that error. We can't find the maximum value of something when we're trying to compare a string to an integer. It doesn't really make any sense there. Okay, so otherwise that is it. Tuples are super straightforward. Again, they're kind of read-only. Once they've been written to once, that's it. You can't really modify the value of the tuple. We saw a couple of the functions that we can call. Again, there are actually a few more functions that we can call on tuples, but they all follow this sort of format. These are the only tuple-specific functions. Cut it. So let's go over what we'll cover. We're just going to start by creating some dictionaries, then we'll talk about how to access and modify dictionary elements, and then just like before, we'll go over some common dictionary operations. Now, dictionaries are a little more complex. There are lots of operations. We'll again just cover the more basic ones, the ones that we'll find ourselves using more often. If you want to learn more afterwards, then turn to the docs. So let's head on over to the code. First things first, get yourself a new cell started. We'll be writing the code within the cell. We'll probably have to take a couple cells to do so. Okay, so before we get started, let's talk about what we're going to be doing here. So the first thing to note when using a dictionary versus just a list is that the dictionary is based on key value pairs rather than just indexes and values. Okay? So with a list, the index or the position of these items is important. Okay? If I need to retrieve an item from my list, I need to know its index. So I can use methods to help me find the index of it, and then I can retrieve it through that. Okay? But the position is very important. If I shuffle these, then it becomes an entirely different list. However, with dictionaries, the index, the position or the order really doesn't matter. It doesn't matter if the item I'm looking for is at the front, the back, or somewhere in the middle. What's more interesting to me is under what key that value is stored. So rather than storing items at positions or indices, we store them at keys. Now we can also use the keys as other values. For example, what we're going to do is build up an inventory. Well, in our inventory, I know we've already done this a few times, but this one will be a little more comprehensive. We'll have items, and then we'll have the quantities of those items together. So kind of like with this tuple, we have the name and the quantity. That's what we're aiming to build, but lots of these instead of just the one. Okay. So I guess what we can do is go ahead and get started, and then that'll be a bit more easier to understand where we're coming from. So we'll create an inventory. It's a good thing types are flexible in Python. And within this, we're going to, within these curly brackets, so this makes a dictionary, we're going to put our key and value pairs. So the keys and values can be of any type we want. we can have, for example, integer keys and string values. We can have Boolean keys and integer values. We can have string keys and integer values again. It really doesn't matter as long as they're consistent. So we would have all string keys or all int values, otherwise things get a bit confusing. So in our case, we'll have the string names and then the int values. Okay? So this makes sense because each of the quantities of the items will be stored under the name. So let's just enter some random items. I'm just going to populate with some stuff. So we'll have a knife 1, we'll have have a few health kits. Let's have 3 of those. We can have, I don't know, some wood or something. Pieces of wood. And we'll have 5 of those. Okay, so let's talk about the setup here. Again, curly brackets to indicate that we're dealing with a dictionary rather than a list.
En vérité, les dictionnaires en Python, c'est n'importe quoi. En Lua, c'est tellement plus simple.
Each of the elements is this kind of key value pair separated by the colon, so that's how we know it's a key value pair, and separated by the commas again. So, whereas before, each of the list items, even if it was a whole list, is considered an element like this, okay, or just a single value like this. In a dictionary, rather, this is considered one element of the array, this key and value pairing. All right. Now, even though there are technically 2 values at each index, there's both the key and then the value associated with it, we're going to consider these as the values, okay, and these as the keys. So they're kind of 2 separate entities. When I talk about dictionary values, what I really mean is these guys here, not necessarily the keys. Alright, so that begs a question, how do we access these items then? If it's not index-based, if the order doesn't matter, then how do we get the values stored in this dictionary? Well, there are lots of ways. First of all, we can use square brackets, just like before, except that instead of entering an index, we enter the key, and that will retrieve us the value stored of that key. We can use a get function, we'll explore that a little bit later on, or you can get all of the list, get a list of all of the keys and all of the values and go from there. So we'll kind of explore a few of those. The first and perhaps the easiest one is just using the square brackets. Let's say I want this value here. I do my inventory and I get the value stored at this key of knife. Okay, I can go ahead and print that out if I want. If I run that, it'll just print out 1. Same with if I printed out health kit. Okay, should be capitalized, case does matter. Okay, we get 3 and so on and so forth. So essentially I'm entering my key and I'm retrieving the value. So this is very similar to just entering an index and retrieving whatever value is at that index, but in this case it's key associated, not position. Okay, cool stuff. So that also goes for modification. Now let's say I wanted to, actually I guess we'll cover 2 things first. One, inserting elements, and the second, modifying elements. So let's say I want to modify, I picked up another knife, so I want to modify whatever value is stored at knife. So now I'm going to set it to 2. Okay, let's print out my inventory. Cool, so we'll go ahead and run that. You can see that we've now reset that value there to 2. Realistically, what we would do is like plus equals 1 or something, but you know, that's different. So we've set the value to be something different, okay? Alternatively, what if that value, if this key value pair doesn't exist? Okay, we could use like an insert function, but there actually isn't really an insert function for a dictionary, and that's because it's not needed. Instead, what we can do is just say inventory of some other key. So let's say we acquired some gold, we acquired 50 gold. What we do is inventory of gold is equal to 50. And don't worry, this will run, even though that key doesn't yet exist. Because if the key doesn't exist, then it creates a new key value pair based on whatever value we associate, and then inserts it at the end. So if we once again print out inventory, I'm just going to copy and paste that, then we should see that we have gold and 50 added to the end. So using this technique, if the key exists, it replaces the value. If the key does not exist, it creates a new key value pair and then inserts that at the end of the dictionary. Now, there is no insert method, or insert function, for those of you who don't really know object-oriented programming, because the order really doesn't matter. It doesn't matter if I stick my new key value pair on the end, or at the beginning, or in the middle, because the order is completely irrelevant, okay? Instead, what we're interested in is, again, that key value pairing. Okay, so we've seen how to retrieve, how to modify. What about some of the different functions that are involved in these dictionaries? Well, for that, I'm actually going to go ahead and start a new cell. Yep, we'll do that. I'm going to copy over this original inventory just so that we kind of get it resetting every time and don't get the weird state change issues. Okay, so I guess I'll start by talking about the get function. Okay, and that's if we're trying to retrieve a value for a key that doesn't exist. So let's say I forgot that I didn't add gold to this one, and I'm trying to get whatever inventory of gold is. Okay, and I'm going to print it. Basically, I just want to see how much gold I have in my inventory. Okay, well this right away is giving me an error, which is annoying. This would crash your program, saying we don't know what gold is. There's nothing in this dictionary called gold, so we can't fetch it. So that's a big problem, because I don't necessarily know, I mean, here I do, but in my actual game I might not necessarily know whether or not I have gold in my inventory. Okay? So the easier way to check this is to use the get function. So instead of doing this, because this is going to cause our program to crash, what we can do is do inventory.get, okay, and then enter the key that we want, and this I'm going to print out. Okay, so go ahead and run that. So instead of my program crashing, I get none. Now this makes sense, because again there is no value associated with this key, because this key is not a part of our inventory. So this function definitely is more flexible, it's more useful than just doing things this way. This is kind of the quick, easy way, but I would recommend, where possible, to use your get function instead, because instead of your program crashing, you get none, and then what you would do is check to see if that is equal to none. If it is, then we don't have any gold. Alright. Now the alternative way would be to get a list of all of the keys and check to see if gold is in that. So that's easy to do as well. What we can do is select our dictionary name, so inventory, and spell it properly. So inventory, and we can just get the keys. Okay, so let's just go ahead and print that out, and same with the values actually, might as well do it at the same time. Values like so. Okay, so this now returns me a list. It's actually technically an iterable type element, but we can kind of treat it like a list of all of the keys, so knife, health kit, and wood, and then the values 1, 3, and 5. Okay, so if for whatever reason this didn't exist, what I would do is I would get my keys, I would search through keys using probably a loop, and say, are any of the keys equal to gold? If they are, then I want the value, and if we get to the end of the loop, if we get to the end of the list, and there are no keys, no values associated with that key, then I know it doesn't exist. Okay? So we've seen how to modify, how to add or insert, but what about removal? Okay, so for removal, we can use a pop function. But it's not quite like the list pop function, because remember, the list pop function just takes the last element off the end of the list. For a dictionary, we have to enter the key, and then it removes that key value pair. So what I would do is I would say inventory.pop, and then the key, so in this case maybe we'll pop the knife off, dropped it, or something bad happened, and then we'll just go ahead and print out our inventory. Oops. Wow, really not spelling that properly. Okay, and then we'll go ahead and run that. Okay, and this is going to basically get rid of knife, not only the key, but also the value associated with it, because otherwise, if there's no value with the key, then it essentially disappears. And then you can see that's given me the updated inventory. Interestingly enough, this pop function actually also returns knife, so we can actually print out the result there. That should return us a tuple with the knife and then the value. Actually, I guess just returns the value. In this case, it is 1, which makes sense. Okay, there was a 1 associated with this key. I guess we don't even need the tuple because we know what the key is anyway. We can put that in a tuple if we want, and so on and so forth. Also, if we want to clear the thing out, we can call upon the inventory.clear function like this. It's going to be our dictionary.clear, and that gets rid of everything. So basically, just clears out our inventory just like before. Also, we can get stuff like the length. Okay, we can get the max, and we can get the min as well, just like with our list. So we can get the min of inventory. I'm actually not going to clear it because we want to be able to actually get these. So I want the length of my inventory. Okay, I also want the min of my inventory, and then the max of the inventory as well. Okay, so these actually do work. Oh, actually, I should probably be printing these out. Let's do that. Print and print. Okay, we'll just close off the brackets there. Okay, there we go. So the length is 2. If you remember, we actually removed something, so this is what the inventory looks like. Makes sense that there are 2. the minimum of our inventory is health kit and the maximum is wood. So interestingly enough, guessing the minimum and maximum actually does so based on the keys and not the values, okay? Or rather, it does so based on the value associated with the key and not that. So this is kind of hard to demonstrate because this is also smaller in alphabet as well, so it could have been that. So let's actually go ahead and add something to inventory. And do inventory, and we're going to say, just to demonstrate this point, we'll do maybe apple. Okay, and we'll have 10 apples. Okay. Oh, that should be... Apple is equal to 10, like that. Okay. So we'll go ahead and run that. And this time the minimum is apple, alright? So because the apple key is the least value when it comes to our keys, then it's going to, we're basically going to return that instead of the health kit in this case. Alright, so that pretty much covers the basics of dictionaries. Like I said, there are more functions to explore. I would definitely recommend you check them out. Dictionaries are very, very useful. They kind of help us avoid long if statements, and especially if we don't really care about the order of items, but we want to know exactly what key they're stored under, dictionaries are going to be your friend. Okay. So we'll go ahead. Run that, and this time the minimum is apple, alright? So because the apple key is the least value when it comes to our keys, then it's going to, we're basically going to return that instead of the health kit in this case. Alright, so that pretty much covers the basics of dictionaries. And add something to inventory.
qui sert à rien, quoi. C'est une dinguerie, ça. Faire le minimum sur une clé pour l'ordre alphabétique, on s'en bat les couilles.
Okay, so we have now just finished our first work block, and it is time for your guided 10-minute break. Now, one of the issues with these work rest session structures is that a lot of students get completely derailed during their break, or they don't let their brain properly recover or relax. So in this 10-minute rest, I'm going to guide you through an activity that's going to help you not only recover, but actually make your next session even more productive and locked in than the previous one. So I want you to stay here and follow along for the next 9.5 minutes, unless you need to go to the bathroom, in which case, please do. Don't relieve yourself on the floor. We're going to start with keeping our headphones on, and we're just going to change to some more relaxing music. And next we're going to grab a piece of paper or a blank canvas on your tablet. What we're going to do is some doodling, and don't worry, you don't have to be an artist. Just bring yourself back to when you were just a toddler scribbling on the wall with a crayon. And as you do this, I'm going to explain to you why this is actually effective at helping you with your focus. Don't try to make any artwork. Just create patterns. Look for just repetitive, nothing too strenuous, nothing you're really thinking too much. Just create whatever scribbles you want. So there's actually some research that shows that this kind of repetitive doodling is beneficial for increasing your focus, reducing stress, and helping you activate these neural pathways that are better for creativity and problem solving. And that transfers through into your study and your work. And just a few minutes of doodling can help you to mentally reset and regain focus. And you'll notice that when I changed the music, I changed it to something that's a little bit more relaxing. This is Brain FM's relaxation track, and the cool thing about the music that you're hearing right now is that it's actually a patented technology that the US government's National Science Foundation funded, and it's research back to improve focus and to induce flow states. Back in the day, I used to just listen to rain sounds all the time, but now I pretty much exclusively listen to Brain FM. It's the reason why I actually reached out to Brain FM to sponsor this video in the first place. But Brain FM actually even personalizes your music selection, so I actually tend to get a lot of rain sounds still. So just keep listening to this as you doodle, make those patterns, scribble whatever you want. And if you want to try Brain FM out for yourself, then there's a extended trial link that you can get in the description. It's brainfm/Justin Sung. You get a month of free access. And I will shut up now and let you doodle. And because I know you guys, I know that some of you are watching this, trying to make your doodles better than mine. But it's not a competition. Just relax. Unfortunately, doodle time is coming to an end. Hope you feel relaxed and locked in. We're going to get back into our next round of studying, so get your study stuff out and let's get back into it.
And do inventory, and we're going to say, just to demonstrate this point, we'll do maybe apple. Okay, and we'll have 10 apples. Okay. Oh, that should be... Apple is equal to 10, like that. Okay. So we'll go ahead and run that. And this time the minimum is apple, alright? So because the apple key is the least value when it comes to our keys, then it's going to, we're basically going to return that instead of the health kit in this case. Alright, so that pretty much... with start and end parameters. This will be kind of start and end values. We'll show you how to use them in combination. Then we'll talk about how to add in a step parameter. This will allow us to skip numbers. Then we'll talk about how to reverse a range, and finally use the in and the not in operators. I figure we'll be looking at those in our for loops a bit later on, so we may as well get used to using them now. So let's head on over to the code. Last time we covered dictionaries, that was number 12. Here we're number 13 with ranges, so we'll want to first of all get started with a new cell. Okay, let's just zoom in so you guys can see it, and we'll get started down here. So first of all, ranges, what are they and how do we use them? So we know that ranges are just lists of consecutive whole numbers. We can specify what number we want to start at, what number we want to end at, and we can also specify a step parameter that allows us to skip numbers. This is a very easy way to, let's say, just get whole numbers, or maybe every third number, every fourth number, so on and so forth. When I said whole numbers, actually, I meant even or odd numbers, because they are, of course, always going to be whole numbers. So that's what ranges are going to be used for. It's basically just a really quick, easy way to create a list of consecutive whole numbers. Okay, so to create a range, you use the range operator like this, okay? And within the range, you can just specify your start, your end, and your step. So you don't need all three. At the very least, you need an end parameter, okay? Because if you just specify an end, then it will start at 0 automatically. One thing to note is that your end number is not included in the actual range. So let's say we want the first 10 numbers. You'd think that you'd do something like this. First 10 is equal to a range, and we'll go up until 10. So this will get 0 through 10. However, this is not going to include 10. So let's say we print out the first 10. Okay, just like this. This is not really going to do anything fancy. It's just going to print out a range. That's boring. Basically through numbers 0 through 10. Okay, we want the very first element. We can actually use the list square bracket syntax. That's fine. That's good. But what about the last element? Okay, so index 10. That actually doesn't exist. Okay, and that's because 10 is not included. If we did 9, the index of 9, that would give us the number 9. So we are guessing 10 numbers, but we're starting at 0 and ending at 9. So that's not exactly what we want in this case. In order to get the first 10, like numbers 1 through 10, what we would do is, let's call this, I guess we have a first, we can do first 10 again. That's fine. It's probably more accurate this way. We can start at 1 and then end at 11. Okay, well, that way we get exactly what we want. We can take these, print them out. Okay, and now we're getting what we want. So we're starting at 1 and we are ending at 10. So it's important to note that when you're doing this, the start number is included, the end number is not. It's basically just that minus 1. Okay, now what about the reversed? You'll very often see if you're kind of counting down instead of counting up, you'll want to reverse this range. It's actually very easy with the reverse operator. So we can just call this something like reversed 10 or something is going to be equal to the reversed operator applied to maybe our first 10. Okay, so this should give us the numbers 10 through to 1. However, because this actually returns an object of type iterable, if we print out reversed 10 like so, okay, we'll actually get something different. Okay, you see that we get a range iterator object rather than just that range 0 through 10 or whatever it was. Okay, so this can't really be, we can't use this to access our items like this through the subscript syntax. It doesn't work. So what we would have to do is convert this to a list, and then we can access items. So that's fine. What we can do is just say reversed 10 is equal to a list of reversed 10. Okay, and then we can access the elements like this. Okay, so no problems there. In fact, we could print out the entire list and we would see all the elements just like when we printed out a regular list. Okay, you can do this with the reverse list, or reverse range rather, or just with a regular range you can convert it to a list, no problem. Okay, the final thing I wanted to talk about is the in and the not in operators. These basically are used to determine if a value exists within a range. We can also use them on lists as well to see, like in this example, we have a list. It's not actually a range or an iterator object anymore. It's actually a list object. We could say, is 6 in this list? Yes or no, okay, and that will return us a Boolean value. So the in operator is always going to return a Boolean value. It's either yes, this is in it, or no, it's not in it, and the reverse is true for not in. Okay, so let's just take a really quick example. Well, I think we'll stick with let's stick with first 10 because I think it's nicer than reverse 10. So we know first 10 is basically a range object, okay, with numbers 1 through 10 inclusive. And we just want to test to see if 5 is in it. Okay, we know that, but let's pretend we didn't. So we want to print, actually, yes, I guess we could just print this. Let's say 5 in first 10. Okay, so we get true printed out. Makes sense, there are numbers 1 through 10. Of course, 5 is going to be in that. Okay, same with if we do not in, that will just kind of give us the reverse, so that's going to be false because we know that 5 is in first 10. Okay, we did like 15 or something, that will return us true because we know that 15 is not in the first 10. Okay, so when used like this, the in or the not in operators will always return true or false. We're actually going to see when the in is applied with a for loop, it's going to be used very slightly differently. It's actually no longer a comparison or like a check. It's actually going to be used to access each individual element, but much more on that later on. Okay, so that's pretty much it. Again, ranges are very, very easy to use, probably the easiest of all of the collection types. It's just a way to build a list of consecutive whole numbers. We can convert them to actual lists for kind of easier access and use. We can reverse them pretty easily. We can, oh, actually, we didn't even demonstrate the step operator. I guess I'll go through that one really quickly. Let's say we're doing the numbers 1 through 10. Like this inclusive, and we want only the basically want to skip every other number, so we would skip all of the even numbers there. What we could do is we could say something like print, I guess we could create a new range, so let's say I guess we'll probably have to convert it to a list if we want to print it out, so we're going to create a list of a range of 1 through 11, and we're going to skip every other one, so we're going to say skip by 2. Okay, so let's go ahead and run that. Right, so here we go. So we get the odd numbers being printed out only, 1, 3, 5, 7, 9. Note that it actually doesn't print out 10 because it's skipping that one, okay? So essentially this will start at this point, and it's going to step by 2. So instead of going 1, then 2, then 3, it's going 1, and then it's skipping 2, so up to 3, and then to 5, and so on and so forth. If you wanted the even numbers only, then you could do like 0 through 11 and skip 2. You just have to alter up your kind of start and end point. Okay, so that's it for now. Do play around with ranges a little bit, and especially the reverse ranges. Remember, they are different objects technically to lists, although you can see that we can easily convert ranges, even reversed ranges, to lists. And when we come back, we'll be talking about control flow. So stay tuned for that. Thanks for watching. See you guys in the next one. Here we're going to start a new topic of conditionals. We're going to learn what they are and cela for short. Conditionals allow us to choose which parts of our code we want to execute based on the which code we want to execute, or how the program should be testing the value of a single variable, or just maybe a Boolean variable, but either or it could be testing equality between variables. Is some value greater than another? Is some variable equal to something else? Our first test fails, we need a backup test because there might be multiple states that we need to test for, and we need to provide different code or rather execute different. What's up guys, welcome to the 15th tutorial in our Python. It's the previous tutorial that was just kind of an intro into control flow. So let's go ahead and, as per usual, start up a new cell. Okay, so for this example, I would like to kind of bring things back to a video game example, and what we're going to do is we're going to simulate player movement. Now, player movement can be very complex. We're just going to think about something super simple where it's just kind of a two-dimensional plane and you can either move left or right. We're not even going to worry about jumping. So you press the left arrow, you move left, you press the right arrow, you move right. And all we're going to do is actually just print out what you can do here. We're not going to keep track of an X value or anything like that. We're going to keep things really, really simple. Okay, so basically there's two possible options we're interested in, left and right. Everything else kind of falls by the wayside. But for now, let's just pretend we can only move right. So we'll have a variable here and we'll call this key press, and we're just going to set this equal to, we'll say right. Okay, so this is going to represent right, this will represent left, and so on and so forth. So what we want to do is we want to see if the key press is equal to right. If it is, then we'll print that we're going to move right or something. So the way we create an if statement is like this: if, and then the condition. Some languages will use brackets, but not Python. So we're going to do if key press equals right, okay, and then we have to finish it off with a colon. So this colon signifies the end of our condition that we're testing, okay, and then any code goes underneath, but notice how it's indented. So again, Python kind of gets rid of the brackets and the curly brackets notation. Instead, we have the colon to signify the end of our condition, and then we need to make sure everything is indented. So I'm just going to press tab there, and you'll need to keep cutting this consistent indentation. So in our case, all we want to do is print something like move right. Okay, if we wanted any other code, note how as soon as you press enter or return, then it keeps the same indentation. If you're done with the if statement and you want some other code, then you need to make sure that the indentation is not the same here. Okay, because otherwise that signifies kind of the end of the if statement. Okay, good stuff. So let's go ahead and we'll just run the cell. Okay, it should print out move right because these are equal. Okay, and just being a little bit slow, but don't worry about that. Okay, there we go. We get move right printed out. So what happens if this is something else? Okay, obviously this is 4 keys, but you know, that's fine. So in that case, we got nothing printed out, nothing really happened. And that's again what we expect, because right now we're only handling one specific case. We're just saying if these values are equal, then we'll do this. Otherwise, there's really nothing else happening. So that's where the elif can come in handy, because realistically we want to test multiple possible cases. So for this, we're going to say elif, and then we're going to put another condition here. So we're going to say if key press goes into account. So realistically what we could do is we could just have something like incorrect action or incorrect option being printed out. I know in a lot of games there will just be nothing happening if you press the wrong key, and that's totally fine. That's absolutely a valid option, but we're going to just do this just to demonstrate what's going on here, just because we're using print statements and we're not actually changing any of the positions or anything. So for this we can use an else. An else will cover every other case. So it's basically, well, none of these tests pass, so we need to do something. We still want to execute some code, and so that's what we're going to do. So in this case we'll print something like invalid key. Okay, so we'll go ahead and run this, and we get invalid key printed. So that, again, that's exactly what we would expect, because the first test failed. Then we go to the second test, that failed as well, but we still want to do something. Now I should say that doing this, having an else and then do this, is different from just having some code down here. Okay? The reason this is different is because this only gets triggered if these fail, whereas this will always run regardless. Well, I mean this won't because it's nonsense, but it would always run regardless of the outcome of these tests. Okay, so the else only is executed if everything above fails, but any code outside of the if statement will be executed anyway. Okay, so once again, with any of these, if a test passes, it executes the code and ignores everything else. Okay, so that goes for if, and that goes for elif. Also, if a test fails, then we go on to the next check, and we basically continue to do that until either one of the tests pass, or until we reach the else statement. There is no check being performed here. This is just saying, okay, well, nothing else passed above, so we're going to do this regardless of the state of the program. Okay, good stuff. So hopefully that is clear. This is definitely can be a little bit confusing if you have never dealt with any kind of control flow or conditionals before, so I definitely recommend you practice this. Now the final thing I wanted to bring up is going to be the ternary operator. And the ternary operator basically assigns a value or returns a value based on the outcome of a test, otherwise it returns a different value. Okay, so again, it acts kind of like an if-else combo. Oh, by the way, actually, just quick side note, we can absolutely have if and else without the elif. Okay, so let's say, for example, I was only interested in the right key, then I could definitely cut this out, okay, and just have my if and else, and that's totally fine too. Okay, so back to the ternary operator. The ternary operator requires us to provide a possible value and then an alternative value. So this is a forced if and else statement, because we can totally have an if statement without the else or the elif. So the ternary operator would look something like this. We're going to create maybe a result. We can basically do the same thing as this or this. Actually, you know what? Let's pretend that we're only interested in the right or the left key. Okay, so we're going to ignore everything else. In that case, we could say something like command is going to be equal to move right if key press equals right. Okay, and then we'll do else, it's going to be equal to move left. So I know this is kind of weirdly formatted. In fact, in a lot of other languages, you'll have something like the test condition, and then one value, then the alternative value. And in my opinion, I think that's a little cleaner. It makes a little bit more sense. However, this is just kind of how things are done in Python. So basically, we're assigning this value to this variable if this test passes. Otherwise, we're assigning this value. Okay, so this value if this is true, or this value if this is false. Okay, so that's kind of how it would work here. Now it doesn't make too much sense in our case because realistically we have to take into account whether the user presses the left or right or something else. So there are at least 3 cases. Okay, but this works if there are only 2 cases that we're kind of checking for. So a test case and then kind of the alternative or the fail-safe, but there you have it. Okay. In fact, let's say that we can only move right here. Maybe it would be better if we did something like this and then invalid key. Okay, and then you could print out command or do whatever. The final thing I should note with the ternary operator is it's actually returning a result. It's storing a result. Okay, whereas this, we can really do whatever we want with the if-else statement. See that we're not actually storing anything. We're just printing something here. You can't necessarily do the printing here. Here you're actually returning and storing a value in this variable. Okay, so that is it for now. Like I said, I do highly recommend that you try out your if, elif, and else statement combos. Try various combos. Try maybe an if and an elif together, then an if and an else, maybe just an if statement, so on and so forth. You can't have these without the if statement, just so you know. And maybe also try out the ternary operator. Once you're comfortable with that, we'll show you some other cool things that we can do with if statements in the next section. So stay tuned for that. Thanks for watching. See you guys in the next one. Statements that we looked at previously. Specifically, we'll be taking a look at consecutive if statements, so one right after the other without necessarily an elif. Then we'll talk about nested if statements. Those will be if statements within if statements. And then we'll talk about how to add multiple test cases to a single if statement. This will be done through the use of our logical operators. So we'll kind of go over an example of each and talk about the advantages or disadvantages of using these techniques. Let's head on over to the code now. Alright, so last time we finished off with the basic if, elif, and else statement introduction. Let's go ahead, oops, don't want to do that. Let's go ahead and get started with a new cell. Okay, we're just going to zoom in there so you guys can see it a little bit clearer, and let's launch into the example we'll use. So I figure we'll use actually a slightly different setup than this, a different example. This is using key presses and moving left or right. What I'm interested in, and you'll see why in a bit, is going to be the kind of health and lives functionality. So very often in video games you'll have a certain number of hit points or health, and you'll also have a certain number of lives. The convention, generally speaking, is to take damage, and that gets subtracted from your hit points. When your hit points reach 0, you lose a life, and if you run out of lives, then you die, and that's kind of game over. Okay, so a very common convention across a lot of games. So for here, we're just going to create some variables to represent those to start off with. They're going to have number of lives equal to 3, and let's say health is equal to 100 or something. You pick whatever numbers you want, as long as they of course make sense. You don't want negative health or negative lives. Okay, so our setup is going to be like this. To start off with, we want to say that we're going to take some damage, okay, and we want to check to see what our levels are because we don't know necessarily what we want to do. Let's say if we're at 0 or less health, then we want to subtract a life. And then later on, we'll say that we're actually going to print out another message if we're at 0 lives. Okay. If we're at maybe less than 10% health, then we want to say, okay, we're severely damaged, so be careful. Okay. Very often in some video games, the screen will flash red or something like that. Okay. And then if you're at less than 50% health, then we'll say, okay, just so you know, 50%. Otherwise, we're fine. Okay. So what we'll do is we'll assume that we've already taken the damage and we're now testing to see what health is. So the first thing we want to see is, are we dead, essentially? Or is our health less than or equal to 0? Okay, so if that's the case, we want to just, for now, just print out a simple message. We're going to say something like, you died. Okay, and I know that's a little bit morbid, but that's the reality of these video games with health and lives. Okay, so we can say elif, health, is less than or equal to maybe 10. Okay. We'll say something like, warning, 10% health. Get that for now. We didn't have the elifs here. What if these were just if statements? Okay, now see what happens when our health is 0. Well, now we get 3 things being printed out, so that doesn't make any sense at all. Because we died, so obviously our health is less than 10% and also less than 50%, so these are totally redundant. So this is kind of why we introduced the elif rather than just the if statement, because in this particular case, all 3 tests are technically passing. But because we're calling these elifs rather than ifs, we don't even test these cases as if this one passes. Okay, so that's kind of where we would use if statements versus elif statements. If you do need to perform all of these checks for whatever reason, you needed to perform every single one, then you don't want these in elifs, because if the first one passes, then these 2 don't even get tested at all. So for that, you'd use ifs. For our example, it just makes more sense to do the elif statement. Okay, cool stuff. So next up, we have the nested if statements. That's essentially an if statement within an if statement, and you can go many levels deep if you really want. Generally speaking, where possible, I would discourage this, because otherwise you get caught in this kind of nasty, really deep if statement, and it becomes very difficult to debug properly. Okay. However, there are situations where it can't be avoided, and a lot of situations where it makes sense. If you can keep your if statements clean and simple, then that should be totally fine. Okay, so a nested if statement will occur when we test something, but then we want to provide additional tests. So our example here would be, the place where we'd want additional tests would be here. Because if the health is less than or equal to 0, we need other logic to test. Okay, so in that particular case, what we're going to do is, within this if statement, we'll first subtract the number of lives. So we'll say num lives minus equals 1, so fairly straightforward. And then we need to perform another check, because we need to see if the number of lives is equal to 0. If we have no more lives left, then we are basically, we're done the game. Okay, so here we're actually just going to say we're going to subtract 1 from the lives, and I guess actually we'll do this first. No, you know what, actually it makes a bit more sense to do it afterwards. So we'll subtract 1 from the lives, and we'll say something like, instead of you died, maybe this will be something like you lose a life. Okay, but now we need to perform the check, so we need to say if the number of lives is, let's say the number of lives is less than or equal to 0, well, now we need to do something else. So now we need to say, we need to print you died. Okay, so this makes a bit more sense. Technically we're not dying, well, within the game we're not dying if we reach 0 health, as long as we have some lives left. But if we have 0 health and we have no lives, then of course we died. So in this particular case, it actually makes sense to nest our if statements, because we're executing code before we're performing the second check. Okay, if we weren't doing this, okay, we were just doing this and then immediately this check, we could actually combine these into a single test. We could do something like this: and num lives is less than or equal to 0. So this is basically testing both conditions. This is basically doing exactly the same thing as this without these lines of code here. Okay? So if we wanted to make this a little bit more complex, what we could do is maybe we have a certain number of health kits, and maybe our game is really nice and it automatically applies a health kit if we reach 0 health but have some health kits. Okay, so what we could do is we could say number of health kits is equal to, maybe we'll have 3 health kits as well. Okay, so in that particular case we want to say if health is less than or equal to 0 and the number of health kits is less than or equal to 0, then we want to do something. So then we're going to say number of health kits is less than or equal to 0, then we'll execute this logic here. Otherwise, if the number of health kits is not equal to 0, then we'll just kind of increase our health. Alright, so for that, you can definitely put this logic back in. We can uncomment that, and this should work. We haven't included the logic to kind of heal ourselves back up, but you could definitely put that within this if statement, or you could create another case. So basically say, if health is less than or equal to 0, and number of health kits is less than or equal to 0, or you could do and have an this should be here, an elif. Health is less than or equal to 0, and number of health kits is greater than or greater than 0. Okay, and then you could have the logic in there. We're actually going to skip that out. Like I said, we're not. This is really just supposed to be a simple example. We're not actually building the game and implementing real logic, but this is kind of something like how a simple game might go. Okay, so we've actually demonstrated. As per usual, with a new concept, we'll spend just a few minutes in the slides talking about what it is and what it brings to the table as far as programming goes, before we take a look at some real code examples. For starters, we'll talk about what are loops. Again, this will be just a kind of a general intro into what they are and what they do for us. Then we'll focus specifically on while loops and then turn to for loops. Now, although while and for loops both do a similar thing, they achieve a similar purpose, they run very slightly differently, so we're going to compare and contrast them. So for starters, what are loops? And I guess I should preface this by saying that loops are technically another form of control flow, just like the conditionals that we saw before. Now, loops are different from everything that we've seen previously because they provide a way to automate code to run multiple times. That's different because everything that we've seen up until this point, including control flow, runs at most one time. In fact, with the control flow, we saw that sometimes we're just not really executing any code. Put whatever we else for while loops, so stop running. While loops are extreme because for adopted by the compiler that will kind of run that many times. For loops pair very well with ranges or lists. In fact, we almost always use them with ranges or lists because it can be, I think, about while loops, and then after that we'll have a separate section for loops because I think our if statement variants, the first thing, as per usual, that we want to do is get started with a new cell here. Okay, so let's talk about where we might see loops in a program. Well, actually, I said in our intro to loops that basically most programs kind of run on a loop. So especially you'll see this with games. There'll be some kind of main game loop that is constantly cycling through, taking in player input, updating positions, detecting collisions, etc., and rendering graphics. So I think because games are easy to relate, we'll stick with those examples and we'll kind of simulate a basic game loop here. So we're really not going to get into anything fancy. All we're going to do is simulate player movement, specifically player movement to the right, which means we'll start at a position and we'll end at a position, and once we reach the end, okay, we'll get back to that in a second, and then we'll just increase X position by 1 with each loop iteration. Okay, so this condition can be pretty much anything we want as long as it returns true or false. Okay, and realistically at some point in time we should have some sort of break condition. We should make sure this loop won't run infinitely, so we need this condition to be something that will at some point return false. Fairly intuitive way.
Alright, and that's our second session done. Once again, we'll move into a different kind of guided 10-minute break. I'm going to swap to another relaxing sound here. We've been studying and working for a longer time now. We need a little bit more of that rejuvenation to make our final session that much more effective. And the technique we're using is called box breathing. I'll do this for around 4 or 5 minutes, so hang on until at least then to get the benefit of that. And if you'd like, you can keep doing it for the remaining time. And if not, you can go and take a break and go to the bathroom and then come back before the next session starts. Box breathing is a breathing exercise that is used by high performance professionals all around the world. Actually, I was taught it in medical school, and I know that it's taught in a lot of military applications for pilots, Navy SEALs, and it's a great way of increasing mental clarity, reducing clutter, and helping to improve focus. It also helps to rejuvenate you and recover your energy. And it's very simple. All we're going to do is breathe in for 4 seconds, hold for 4 seconds, breathe out for 4 seconds, and then hold for 4 seconds. And the reason this works is that it actually forces a relaxation response in your body physiologically. It's called the parasympathetic response. And the reason it's called the box breathing method is that you're meant to visualize a box in your mind for each of those 4 seconds. So here's a graphic on the screen for you to follow to make it easier. So we're going to start with breathing in for 4 seconds, hold for 4 seconds, breathe out for 4 seconds, hold for 4 seconds, and keep doing this. Just keep following your breathing using the box on the screen. And every time you do a loop, try to imagine that you're getting more relaxed, that mental clutter is dissipating. One thing that I find really effective for this is to try to notice parts of my body that are more tense. Often when we're really focused and concentrating, we can start tensing up our muscles as well, especially shoulders, face, jaw, our neck. Not only does this give you the I stay at home and study all day posture, which isn't great for our health, but it actually also just creates more stress and tension that we can feel mentally. So when you breathe out, try to focus on those areas and just relax when you breathe out. You might also notice that it is a lot easier to do this if you are sitting up a little bit straighter. It helps your diaphragm come down, which gives you a deeper breath. And actually, we think it's the act of the diaphragm going down that helps to trigger that relaxation parasympathetic response. So deeper breaths produce more relaxation. If you notice that you're getting distracted doing this, which happens to me all the time, then just remember to keep focusing on visualizing that box. It can help if you try to draw the box just mentally as well and follow it along. The act of actually bringing your brain back and focusing it on your breathing and the timing in the box is actually the part that improves your focus. So every time you get distracted and you bring yourself back, that is actually what is helping you to improve your concentration and reduce that clutter. So don't worry about getting distracted. It's bringing yourself back that really matters. There's a few more minutes left. If you'd like, you can go to the bathroom, refill your water, get up, stretch a little bit if you'd like, or if you're kind of feeling in the zone of this box breathing, you can keep going for another few minutes. But we will get started again soon. Stay away from your phone. Don't get distracted. Don't do those energy draining relaxation activities, which you and I both know they're not going to help you relax. They're just going to get you more worked up. Alright, well, in 10 more seconds, we will get started with our next session. So settle in, change the music again to our last focus round, get back into it.
Way of doing this would be something like, as long as the X position is less than our N position, then we'll keep the game running. So in this particular case, we are going to perform the check. If this returns true, then we'll execute the code, and then we'll do the whole thing over again. We cycle back up to the top, perform the check, execute the code, cycle back up, and so on and so forth. So how many times do you think this loop will run, considering that we're starting at 0 and ending at 5? Well, we should run 5 times, because we start at 0, increase by 1, so then it's 1, next iteration is 2, 3, 4, and then finally, when X position is 4, we run this, we increase it to 5, we cycle back to the top, then we test this and it fails, okay, returns false. At that point, we exit out of the loop. And just to make things a bit clearer, I think I'll print some stuff out, so I'll just print out the X position here, and then once the loop finishes running, we're just going to print out something like you've reached the end. Okay? Now, note how, like if statements, in fact this while loop looks very similar to an if statement. Specifically, I wanted to point out the indentation here. So again, Python is indentation heavy. We don't use curly brackets or anything like that, so the indentation is important. This is not part of the loop, but this code is. Also, what we really don't want to do is create the variable inside of the loop, like this, because then X position is just going to get stuck at 0 and then 1, and it will just do this infinitely. Okay, so that's not very good. Basically, anything that we don't need to be rerun while we're in the loop needs to be declared outside of the loop. Okay, so we can go ahead and run this, and it works just fine. We can see that we're printing out 5 of the numbers. We've reached the end, so we're good to go. Note, just make a quick side note that if you did the print before the X increase, you do 0 through 4, but essentially the result is pretty much the same. Now, there's absolutely nothing wrong with this while loop. This works, that's totally fine. But realistically, in an actual game, likely there would be more win or lose conditions based on, rather than to check to see if our X position is less than to the N position, because there will be other situations that should cause us to break out of the loop. Okay, such as let's say we are kind of detecting collision, okay, and we have an enemy at some point that we may or may not collide with. Okay, so I'm just going to create a variable, and I'm going to call this enemy position, and I'm going to set this equal to 3. So I know if we incorporate this code that I'm about to write, we will never reach the end position, but that's okay. Again, it's just a really simple example anyway. So what we're going to do here is we're going to, within our while loop, when we increase our X position, we then need to check to see if we're colliding with the enemy. Okay? So for that, we can do something like this. If our X position is now equal to the enemy position, okay, if that's the case, then we're going to print something like, let's say you collided with the enemy, okay, and then we're going to break. Okay, in that case we should actually change this to, instead of you reach the end, it's just going to say game over. Okay, so what's going on here? What's this break statement, and why did we bother changing this? Well, the break statement is a way to prematurely break out of the loop. So if the break statement is ever reached, essentially this just exits the loop regardless of this. We don't really, the break statement doesn't care about the test, it doesn't care about the state of the program. It basically just says, we reach this, so we need to break out of our loop, we need to exit out. Okay, so if this ever returns true, then we'll exit out of the loop regardless of our current X position. Okay, so this makes sense. If we collide with the enemy, then we want to essentially lose the game, so we're going to stop our main game loop. So let's see what happens here. Let's go ahead and run that. So we get to 1, 2, and then 3, and then it says you collided with the enemy and game over. So that's to be expected. Our enemy is clearly in the way, and as of now we have no means to get around that enemy. Now, realistically, you'd probably have a way to avoid the enemy. Either you'd have some kind of like armor or a weapon you can use to defeat them, or you could just jump over them. Okay, so we'll actually kind of simulate jumping. We're not going to, again, take in controls or anything. What we'll do is we'll just come up with a really simple way to do this. We'll just say y position is equal to 1. Okay, so we'll just pretend that we're, I don't know, flying or something. So we have a y position of 1 instead of 0. So then what we can do instead is, when we get to the statement, okay, we're going to, instead of checking this right away, we're actually going to say if y position, should be lowercase, if y position is greater than 1, okay, we're going to continue. Okay, so what is this doing for us now? Well, essentially a continue statement forces us onto the next loop iteration. So if this continue statement is ever reached, we don't perform this check. Otherwise, if this continue statement is not reached, then we perform both checks. Note how this is if and if rather than if and elif. Okay, so that means both checks are always being performed unless the continue statement is hit. So if we get to here, okay, y position is greater than 1, we're going to run this, and we basically skip over everything else in the loop. So a break will exit a loop, a continue will force a loop onto the next iteration, skipping over everything else that's kind of after it. Okay, so let's see what happens this time. We'll go ahead and run it. So 1, 2, 3, you collided with the enemy. And that's because that's supposed to be greater than 0. We'll go ahead and run it again. Okay, 1, 2, 3, 4, 5. So we reached the end. Game over. We didn't collide with the enemy there. Okay. The reason again being that our y position is going to be greater than 0. I mean, at all times. Realistically, we change that in an actual game. And so we never ever end up kind of executing this code because our y position is always going to be greater than 0. We're always going to continue there. Alright, so that is pretty much all I wanted to cover. Realistically, this is a bit messy. You would definitely be able to implement this code to be a little bit cleaner, but I just wanted to demonstrate the continue and the break statements. Realistically, what we would do is we're done with while loops. Let's move to the next loop. Head on over to the code now. Alright, so we ended the previous section 18 by talking about while loops. As per usual, we'll get ourselves a new cell start. Okay, so let's just zoom in there and begin. Okay, so let's just talk quickly about the structure of a for loop or for-in loop. It will look something like this. For some variable, I'm just going to call it var for short, in, and then some range/list, okay, and then we execute the code here. Alright, so a few things to note. First of all, we always pair this with a range or a list or some kind of other iteratable object. Could be a tuple, could be a dictionary, we get keys, items, etc. But it needs to be some sort of an iterable item. Okay. Next up, we have a variable. So because a for loop visits every member in the specified range or list, this variable will take on the value of the current item we're visiting. Don't worry, that will become a little clearer later on. And then, of course, we have the code to actually execute. Okay. So let's start by pairing this with a range, just to keep things simple. That will be kind of the more the more commonly seen for loop, unless you are specifically iterating through some sort of a list or something. So let's say we have a range from 1 to 5. We just want to print out the first 5 numbers, kind of like before, with this while loop, even though these were technically X positions, but whatever. Okay, so we're going to say something like for I in the range from 1 to 6. Remember, the range 1 to 6 will include the numbers 1, 2, 3, 4, and 5, but not 6. We're just going to print out I. So let's go ahead and run this, and we get our result. Now, a couple things to note here. First of all, is the range. So you should be familiar with ranges and how they work. Again, we include the lower number, but not the higher number. This is kind of 1 less than this number. This will contain all of the whole numbers 1 through 5 inclusive. Okay. If we want to step over numbers, let's say we wanted every other number, we could add a step like this. If we wanted to print things backwards, we can wrap this in a reversed like this, but you guys should already know that from our ranges section, okay? You can even create a range variable like this, just say something like our range is going to be equal to this, okay? And then use our range like so. Okay, that's totally valid as well. So the second thing to note is our variable I. So we can really call this whatever we want. I can call this item, I can call this number, I can call this num. It doesn't really matter. I just use I because it's not really, our for loop is just going to be used to print stuff out. It's not really doing very much. So that's fine, we don't need to give it an explicit name. Realistically, if you are performing a specific task, you should be naming your variables to represent what that task is doing. So if this is representing numbers, just whatever, we're printing out numbers, then you should call this num or number or something like that, but I is fine for now. Okay? So third of all is exactly what I is representing. So again, a for in loop by default will visit every single member of a range or a list. It starts at the beginning, and then it goes to the next member, and then it finishes at the end. Okay? So the way that this would run is it gets to our range, it gets the first value, in this case 1, and then assigns that value to I. We print it out, it loops back up to the top. It visits the next member of the range, which is the number 2. It assigns that value into I and prints it out, loops back up to the top, and keeps doing this until it reaches the end. The final number will be 5. So it assigns that value, prints it out, and then it loops to the top, says, okay, we've reached the end of our range, and so we need to break and do whatever code down here. Okay? Now the other thing I wanted to do is talk about for loops paired with lists, and how to pair our for loops with lists. So what we'll do is we'll just start by creating some list. In fact, I'm going to call this inventory. Okay, and this is just going to be a list of random stuff. So we'll have something like boots, arrows, we can have a bow, sword, whatever we want in here. Okay, so just populate this with some items. Maybe you have like a medieval themed game. So maybe we just want to iterate through this list and just print out everything we want to kind of list all the items in the inventory. That's actually fairly straightforward. We can say for something like item in inventory, we are again just going to print out our inventory. Oh, this should be our item rather, not our whole inventory. Okay, so we can do that. As you can see, we got boots, arrows, bow, and sword. Okay, so that's great. That's even more straightforward than our range, because with the range we still had to specify a start and an end position, or end condition rather, but with our inventory, our list here, we didn't even need to do that. We just needed to tell it that we have a list of items and we want to do something for each of these. So once again, the item variable here is going to take on the value of each of these as it reaches it, and then it prints it out. One other thing I should note is that if we don't really care about this value, so let's say for whatever weird reason, we want just to print out our inventory 4 times. Okay, so each time we visit a member of the inventory, we want to print out the entire inventory. Not sure why we'd want to do that, but let's just say we did, which means we didn't need this variable. You can actually replace that with an underscore, okay, meaning we don't really care about that value. But generally speaking, it's better practice to do this and to actually assign and use that variable. Alternatively, what we could do is use a range from 0 to 4, okay, and use that to access an inventory at an I, okay, and print that out. So something like this. For I in range from 0 to 4, in fact, we could just say range up to 4, we're going to print out inventory of I. Okay, so this will do exactly the same thing as this, but this is much cleaner syntax, because what if we don't know the length of the list? This doesn't really care. Okay, this figures out what the length of the list is, the size of the list is, and then it takes care of all of that work for us. Okay? Now, there are two more things I want to go over really quickly. One is that we can absolutely use our continue and break statement, so a control flow statement in our loop, in our for loops. Okay, so these are absolutely not restricted to while loops. We can use them as necessary in our for loops. So let's say we wanted to break out of our loop prematurely. We only wanted the first two items. Okay, so what we could do is, I'm actually just going to comment these out because I don't want them printed multiple times. I could say something like print the inventory I, and then if I equals, let's say we want I equals 1. Okay, so we've got 0, print that out, 1, print that out. If I equals 1, then we just want to break. Okay, so that works just fine. I mean, it doesn't really make much sense that we would do something like this, but just know that it can actually work. Same with continue. We can absolutely use those. Loop will run. Whereas for in loops have a very specific structure. We know exactly how many times a for in loop is going to run. Okay, so if it's something like a game loop, you don't know how many cycles that game loop will run. Maybe it'll be 1,000. Maybe the player will die right away, so it'll only be a few. Maybe the player will play for hours, so it could be hundreds of thousands or millions of iterations. We don't really know. But with a for in loop, we're always pairing them with a specific set range, a finite range, and a finite list or something like that. Okay, so just a really quick example of how we might convert this into a while loop. Actually, it might end up looking something very similar to this. We basically just want this functionality here. We could create an iterator variable, so let's just say I is equal to 0, and then we could say something like while I, we don't need brackets, I is less than 4, okay? Or we could just get the length of our inventory. That's probably better practice. Inventory. Okay, in that case we could just print out inventory of I. Okay, and then we of course need to increase it by 1, because otherwise that loop will run infinitely. Again, I'm just going to comment that guy out, comment that guy out, and we should get probably exactly the same result. Okay, boots, arrows, bow, and sword. Alright, so easy conversion, for loop to a while loop, but we can't always do it the other way around. So that is pretty much it for now. We covered a fair bit within our for loops. Again, pair them always with ranges or lists. What I would like to see you guys do, although I mean I won't actually know that you guys are doing this, but I recommend that you practice your for loops a little bit, especially practice with ranges. So maybe practice printing out every other element, so just boots and bow or something like that. Maybe using a step in your range. Maybe try. Our Python Language Basics course. Here we're going to start a brand new topic. This will be all about functions. As per usual, we'll just spend some time in the slides talking about what functions are and what they can do for us in code. We're going to start by covering what are functions, again exploring these from a is that 0 or more of these. Alt variables or default values for these parameters we can choose a return statement. It breaks and it may output a value if we are returning a specific value. or produce output. We choose exactly when and where we want to execute these functions. The benefits are in code before. Don't worry, they're really not that intimidating and they're quite easy. To cover first how to implement a simple function. Well, the one we covered here was number 19, where we went over for loops. As per usual, we want to get started in a new cell. Just zoom in there for you guys, and let's go ahead and get started. So first of all, let's explore the syntax of Python functions. It's actually very straightforward. We start with the def keyword to kind of tell the compiler that we're defining a function. Okay, and then we have the name, we have any parameters we need, and then the colon, and then the code goes down here. So again, we're not worrying about curly brackets. Most languages I personally have used have the curly brackets, not so much a thing in Python. We do need to worry about the indentation, however, so make sure that you have all of that down. Okay, so what kind of example are we going to go over? Well, there are plenty of examples in game development, and perhaps a simple move function would be useful. So we're going to do something really simple for now to start off with, and we'll expand upon it in the next sections. What we want to do essentially is take some kind of exposition. Every time we call upon the move function, we're going to increase the exposition by 1, and that's going to be it. Okay, so we'll have a variable called exposition, okay, and we'll just start out with 0, that's fine. We'll have a function which we'll call something like move. Oops, move like this, okay. We're not going to worry about any parameters or return values for now. Let's just get the basic function concept down. So name, no parameters, but we still need to add the brackets even if we have no parameters there. We've got the colon and then the code in here. So all we'll do is we'll say xpos plus equals 1. Okay, so that's a pretty straightforward function. Now, if we want to call upon this function, what we would do is we would call upon it like this. So you call upon a function by specifying the name of the function, and then the regular brackets beside it, and then any parameters that need to be inputted into the function can go in here. So if we just do this, I need to modify my function outside of the function, but used within the function, it's considered a global variable. So a global variable is a specific. So when we create a variable within a function, it's considered local, which means it doesn't exist outside of the function. It just so happened that I have two variables with the same name. I could have called this something, I could have just called this x if I wanted, okay? So declare a variable in a function can only be used in the function. If I declare a variable outside but I want to use it in a function, I need the global keyword. Right. So that's good stuff. We have now implemented a very simple function. We've learned how to execute it, and we can continue to do this as many times as we want. Let's say I want to move 4 times. If I can do this, then it should build up. X is basically increasing its value, and because again we're using the global scope like this, keep in mind that you can absolutely add control flow into a function. You can add while loops, for loops, if statements, etc. What's up guys, welcome to tutorial 22 in our Python language basics course. Here we're this, okay? Also, realistically within a game, there are kind of the boundaries of the world. You cannot go beyond those boundaries. So for that we're going to use a parameter, and this will act as input into our function. So we'll just call this something like byAmount. A lot of languages require you to set a type, say integer. Not really the case with Python, we don't care because types are flexible anyway. We just need to specify that there will be a parameter called byAmount that we can use in our function. So in our function body now, we're just going to replace that one with byAmount, and we're good to go. However, now when we call upon this function, we need to pass in that value. So let's say we want to move by 1, just like before, that's fine. We can do a move of 1. And we can print that out. So let's print out our final x position, we'll give this a run, and we get 1. What if we wanted to do the same thing here? We want to move by 4. Well, now we can move by 4, and we get the same result. So 1 function call versus 4 function calls. This is so much more efficient than doing this, and you'll see an enormous increase in efficiency when you're trying to do this, let's say 100 times. The other thing that we can do here is if we don't always pass in a value, we don't necessarily know by how much we're moving, but we need there to be a value, we can use a default value. So for that I can say byAmount is equal to 1, that way we're at least moving forwards by 1, okay? and I can completely omit this. So if I go to run this, I get 1. So this is called a default value here, because we're saying that if we don't have a specific value assigned to by amount, we'll just default it to be equal to 1. So when we call upon a function like this with no parameters, but it has parameters here, it will take on the default value. If we didn't do this, by the way, and we tried to run this, it's going to give us an error saying that we need some value fed in. Okay, so that's why doing this kind of says that if we don't pass in a value, we'll just default it to 1. If we don't want to use 1, we can definitely specify a different value instead, okay, and that's totally legitimate. Alright, so if you know you will always pass in a value, you don't need to worry about the default parameter values, that's fine. If you're not sure about whether or not you will always pass in a value, probably best to use some kind of default value here. Alright, so that is a simple improvement. Now we can even go backwards. We could say -5 to decrease our position, and so on and so forth. Now the second issue is the problem with going out of bounds. So we want to make sure basically that we can't go too far to the right or too far to the left, because we're not worrying about Z or Y positions. So for this, we're going to kind of have our move 3.0. So I'm just going to add in a new cell, actually. Probably best that we start there. Again, just going to copy this over. Alright. So essentially what we want to do is we want to be able to check to make sure that we're not going too far to the left or to the right. If we are, then we're only going to go as far as the start or end positions. So I think probably the step 1 will be to create some variables to represent those. With a start position of 0 and end position of maybe 10. Okay. And essentially we'll just make sure that we're not going less than 0 and not going greater than 10. Also, just the way that this should be structured to kind of be better at code practice is that we're actually not going to create this variable, or we can create this variable now, but we are not going to call upon it from a global perspective. We're actually going to pass in the x position when we call upon the function. So we're going to move by an amount, we're going to have a specific x position passed in, okay, and that means that we no longer need the global variable. Because we're essentially saying that we will always pass in some x position, and we're increasing that x position by this specific amount. Okay, so that's great, but again, there's still no bounds checking. And also, this is now no longer going to affect this x position variable. So what we want to do is output the new x position. So we're going to return our x position, like so. Okay, so now when we call upon this move, let's say by amount, we want to move by 5. We're going to pass in our current x position, okay, and then we're going to output a value. So this is actually outputting something. So we can say something like result is equal to this. If we want to print result, actually, you know what, result doesn't really make much sense. Let's do final x position. Okay, and then we can go ahead and run that. Now this is actually giving us an error, just because we have a default value and Python is weirdly specific about the order of things. So actually, let's do this. We'll do x position first and then by amount equal to 1. So if you are adding default values, you have to have your default value parameters on the far right side of things and your non-default on the far left. Okay, so there we go. We get 5 printed out. Okay, so we start at 0. That's whatever value we're passing in. Oh, actually, this should now be switched. So this is going to be x position at 5, like so. Even though the result should be the same. Okay. So now what we're doing, moving with x position of 5, we're just getting whatever value here. We're passing that in. We're assigning the value of 5 to by amount because we're explicitly assigning a value. We're overriding this default value. We're taking 0 rather. We're adding 5 to it, and then we're outputting it. So we're outputting the new x position. When we call upon the function, we pass in those values and we retrieve the return value, store it in final x position, and then we're printing that out. In fact, we could short form this just because we're only printing, really, to doing something like this. Okay, we don't even need to create the extra variable. This function is going to output a value anyway, so we can absolutely do that. We're just going to basically use the result of the function return. Now it should be noted that this return will break out of the function immediately. Doesn't matter what other code is under here, okay? Obviously it's not real code, but if there was any code under here, it wouldn't be executed. And that's because as soon as a function hits a return value, it exits. We could just do something like this, and that would cause it to exit as well. All right? In this case, we actually do want to output something. Now, this means that you can be clever with your conditionals to make sure that under some conditions it exits prematurely, and under other conditions it doesn't. Okay? So this is a bit like using break statements in while loops, like above. So we can use a break statement here to exit out prematurely. That's basically what a return statement is doing as well. In our particular case, what we want to do is make sure that we're only returning we're returning the correct X position. That means that we can't return a value that's negative or greater than 10. So rather than just returning the X position, what we're going to do is do a bit of checking. We want to say if X, we don't need the brackets, if X position is less than 0, okay, less than our start position, we can, you know what, let's be better, we can have these as global variables. So we'll do global start position and end position. And we're going to say if the X position is less than our start position, okay, then we're just going to return the start position. Okay, this makes sense. We don't want to go less than 0, so we're just going to return 0. Okay. Then we'll say elif X position is greater than our end position. So if we're more than 10, we're going to just return the end position. So again, we cannot go below 0 or above 10. Okay, and then otherwise we're just going to return X position. Now at this point you might look at this and say, where's the else? Why are we not doing else return it? Okay, so that's fine. If you want to do else, there's absolutely nothing wrong with that. The reason I do this is because I actually don't need the else. The reason being, if any of these tests pass, we're going to hit that return statement and we're going to break out immediately. We're not going to do any of the other logic or anything like that. So if this was the case, we hit this and we ignore all of this code. We only hit this code if the above tests fail, so essentially an else case anyway. Alright? So that's just kind of why I'm doing that. Okay, so let's go ahead and run this. Again, we get 5, that was fine, there was no problems there, because we're starting at 0, we're only going to 5. Let's say we start at 0 and we're trying to go to 15. Okay, in that case we get 10, because we cannot go up to 15, as soon as we go above 10, we stop at 10. How about if I'm going to negative 15? Okay, in that case, 0. Again, makes sense, we don't want to go below 0, so we just want to stop there. What we could do here, essentially, is say something like xpos is now equal to move of this. Okay, and then we can print out X position. This would probably be a much better way of keeping track of things. Alright, so that is pretty much it. I know we did cover a whole lot in this tutorial, but hopefully I'm sure you guys are super smart and can keep up with this no problem. As per usual, practice is the best thing that you can do. If you're unsure about any of these kind of concepts, then go back and practice them. So if you're kind of struggling here, then definitely try to break things down piece by piece. So try adding just some parameters, and then try adding just talking about what are objects, following with what are classes, and then how do we use classes and objects in our code. We also have a couple more things to talk about, such as inheritance and static variables and functions. Now I figure I would talk about all of these at once in the slides rather than break it for properties and behavior. Now that doesn't really mean a whole lot to us, but think about state as being a mix of all of the values of an object that kind of describe the object, and then behavior being typically to modify the state in some way. Now, I've been using the example of games throughout our tutorial series, and I think that's really, really relevant now. Think about, for example, a character within a video game. Well, a character will have various states, various properties or attributes, okay? These will all be represented with variables. They might have an X position or a Y position, they might have a certain amount of health, an inventory full of items, etc. And a lot of the functionality of that that character would be to modify the state, such as moving about, that would be changing the X and Y positions, picking up items, that would be modifying the inventory, maybe taking damage, that would be modifying health. Okay, so in this way, the state kind of describes the object, and the behavior is typically used to modify the state in some way. These are supposed to be modeled after real-life objects, so if there's something that couldn't possibly exist, that might not necessarily be a great place to represent it in code. Try to keep things as being kind of like real-life models where possible. Classes, on the other hand, are going to be implementations of objects. So this is not so different from implementing a function, that would be the class, and then executing a function, that would be the object. The implementation is there to specify basically how the object should run, but the object itself is doing the actual running. The state within a class is represented with variables. When variables belong to a class rather than just being global or in some random function, we tend to call them fields. So we'll be using variable and field interchangeably here. Behavior is represented through functions. When they belong to a class, these are called methods, and are again typically used to modify the state of an object, so they'll be used to change the variable values, etc. There is also a special initializer function that exists within classes to help set up the initial state, that is, set up the initial variable values. For example, if you were to spawn a video game character, then you'd probably want to assign a specific position, maybe a certain health value, maybe they'll have a name or something like that. We'd use the initializer to set up basically the initial values. We can also use our initializer to create instances of classes, and these are going to be objects. So if classes are the blueprints, objects are the actual items that adhere to the outlines described in the classes. Then how do we use these classes and objects together in our code? Well, like I said, class simply acts as a blueprint for an object. Again, it's just going to be there to tell the compiler that every single object of this type will have these variables, okay, and will be able to perform these functions. We use the initializer again to create instances of these classes, which are going to be called objects, and an object's initial state is set upon what's called instantiation. So when we initialize a class, it's called instantiation. I know that's a lot of different words and they might sound a bit funky, but that's essentially what we're doing. We're just creating what's called an instance of the object, which is basically just using that class to create an object. We can then use the object, once it's been created, to access the field or execute methods. So once we have an object, depending on the access level, but we're not going to get too deep into that, we will be able to get values and change values based on these methods that we've implemented. For example, again, coming back to a video game character, we would probably have, let's say, a move method or a move function that would be, again, used to modify the X and Y values or even the Z values of that character. So then what is inheritance? Sometimes classes need to provide very similar implementations, but there'll be some differences between them. There'll be some unique fields or methods. Now, if two things are very similar in code, we may end up with very similar implementations, and where possible, we want to try to not repeat code. Okay, write the code once, and then we can use inheritance to kind of avoid having to rewrite it. When several classes, or it could just be two classes, are going to be quite similar, we can probably use inheritance. So what that means is that one class can basically inherit everything from another class, but also add its own stuff. Again, coming back to a video game character, a non-player character will have pretty much all of the same behaviors and attributes that a player character would have, or would have quite a lot of the same behaviors and characteristics. However, a player character would have probably additional stuff, because of course a player character is going to be smarter. There'll be stuff that they can do that a non-player character cannot. Maybe a player character would have an inventory, but a non-player character wouldn't, and so on and so forth. Okay, so basically we would design the same system for both, but then the player character would have extra stuff. So that would be a good place to use inheritance. A subclass will inherit from a superclass. So in this particular instance, the player character would be the subclass, which inherits everything from the non-player character superclass. Now, sometimes we can what's called override a superclass implementation of a variable or function to provide a new one. For example, let's say a non-player character can only move left or right. Well, our player character will also want to move left or right, but they also might want to be able to jump. Might want to be able to move up or down as well. Okay, so generally speaking, a superclass will be a more generic implementation. So it will have stuff that is not very specific, whereas a subclass, which is inheriting from a superclass, will gain everything but then implement its own stuff as well. So that means it gets more specific, it has more behaviors, probably more properties, and so on and so forth. Now, the final thing I want to talk about quickly are going to be static members. We won't spend a ton of time talking about static members, but I think it's important to note, important to talk about them because they are very useful. Static variables and functions essentially belong to a whole class rather than just an instance. What this means is that they hold the values across all instances of the class. Now, this is quite different from if we were just to, let's say, create a bunch of non-player characters, because as the game progresses, they would each have their own unique positions, health bars, because some might take damage, some might not. They might have their own unique names. Maybe some of them look and function very slightly differently, but they'll basically have all of these values set up initially to be the same, but they'll change over time. However, with static members, static variables and functions, these operate across all instances of the class. So they'll be basically the same for all of the player characters or non-player characters here. We actually don't have to create an instance to get access to a static member, such as a static variable or function. That's different from the
And that completes our third and final cycle. Congrats for making it through. If you guys felt focused and enjoyed it, then make sure to check out our friends at brain.fm for more focus and relaxation music. As I said, I exclusively use Brain FM whenever I'm trying to do some deep focused work now, and I genuinely think it's a great product. You can use my link to get that extended free trial in the description to check out hundreds of more tracks personalized to your preferences. Thanks for watching, and I'll see you again next time we study.